Lesson 83, product rule with variables and the power rule with variables. We've already talked about these rules in lessons past. All right, but just as a quick review before we get into some example problems. All right, anytime we're doing problems where we have something raised to a power. All right, if we have a power raised to another power. All right, if you remember when we have a power raised to a power, we multiply. All right, whenever we have powers of like bases. All right, we add those. All right, so power to a power, we multiply. Powers of a like base, we add. All right, so these are just going to be some example problems. The only difference is now instead of numbers that we're raising to a power, we have some variable terms that we're going to be raising to a power. All right, so let's start off with one. We have x to the a, y to the 2x, x to the a over 2, and y to the 3x over 4. All right, in this problem, we do not have a power raised to a power, but we do have powers of like bases. All right, so what we're going to be doing is adding those powers. All right, so first of all, let's look at x. Our x terms, we have x. One is raised to the a, and one is raised to the a over 2. So we're adding a over a plus a over 2, which means we need to find a common denominator. All right, common denominator is going to be 2. So we now have 2a plus a all over 2. Well, if we combine like terms, 2a plus a gives me 3a over 2. All right, so our new exponent for our x term is 3a over 2. Let's look at the y terms. We have y to the 2x and y to the 3x plus 4. All right, so again, we are adding our powers. So we have 2x over 1, and we're adding that to 3x over 4. All right, common denominator in this case is going to be 4. 1 times 4 gave me 4, so 4 times 2x gives me 8x. And again, we're just going to combine like terms. 8x plus 3x gives me 11x over 4. And we have simplified, and that is our final solution. All right, so the only difference is we're doing this with variables instead of numbers, which can tend to get a little trickier. All right, let's try another example. In this next one, we have a to the x minus 2, y to the a plus 4, over, let's go over x to the a over 2, and y to the 2a. All right, instead of multiplying powers of like bases, we're actually subtracting in this case. All right, so let's take our x terms first. Instead of doing a minus 2 plus a over 2, we're actually subtracting. So it's a over 2, a minus 2 over 1 minus a over 2. All right, again, we still have to come up with a common denominator. So we're going to multiply the entire first term by 2 so that we can have that common denominator. We're going to get 2a minus 4. Now keep in mind this is minus a over 2. All right, if we combine like terms, 2a minus a gives me a. All right, so we have x equals a minus 4 all over 2. All right, we did that by combining like terms. Let's look at the y terms next. All right, we have a plus 4. Keep in mind we're dividing, so we're actually going to be subtracting minus 2a. All right, this one's nice because the denominator for both of these is 1. All right, so we're just going to combine like terms. A minus 2a gives me negative a, and then plus 4. And that is our final solution. All right, that is for powers of like bases. Let's look at a couple problems where we are dealing with a power raised to a power. All right, we have x to the a plus 2, and we're going to raise all of this to the second power. All right, so we're really multiplying a plus 2 times 2. We're just going to use the distributive property. All right, our base stays the same. 2 times a gives me 2a 2 times 2 gives me 4. So I now have x to the 2a plus 4. All right, we just multiplied our two exponents. All right, let's look at one that's a little more complex. All right, we have x to the a raised to the b times y to the a raised to the b plus 2. And we're going to throw in some like bases here with x to the negative a. All right, let's raise a power to a power first. All right, in this first one, we have x to the a raised to the b. So we multiply the powers, and we're going to get x to the ab. Then we have y to the a raised to the b plus 2. All right, so we're going to raise the power to a power. We're going to multiply. We're going to distribute that a into both terms. All right, so we're going to get y to the ab plus 2a. All right, that's in the numerator. Now, in the denominator, we have this x to the negative a. Keep in mind that in order to get rid of a negative exponent, we move it to the top and can make it positive. So it's actually going to be x to the positive a. And then we're just going to combine our like bases. All right, so for our x terms, ab plus a, the common denominator is just 1. There's no simplifying we can do, so it's going to be x to the ab plus a, and then y to the ab plus 2a. And that is the solution in simplified form. All right, I'm going to write 2 more examples on the board. One is just strictly using like bases, and the other one is raising a power to a power. All right, so go ahead and work these 2 out on your own. The first one, we have x to the m, a to the 3x, x to the m over 5, a to the x over 2. All right, and for the second one, we're going to do m to the x raised to the z. We're going to do z raised to the m plus 3 all over m to the negative x. All right, so go ahead and work those out, simplify those solutions, and we will come back and we're going to check these when we come back into class.